Okay, let's see what we got today. So I've appreciated the kind of difficulty level of the past few problems. Just not too hard, not too easy, I think. We'll see what we got today. Vowels game. Vowels game in a string. Alice and Bob are playing a game on a string. You're given a string S. Alice and Bob will take turns playing the following game, and Alice starts first. Where Alice starts first. Alice's turn. She has to remove any non-empty substring from S that contains an odd number of vowels. In Bob's turn, he has to remove any non-empty substring that contains an even number of vowels. The player who cannot make a move on their turn loses. We assume that Bob and Alice play optimally, return true if Alice wins the game and false otherwise. Remove any non-empty with an odd number of vowels, an even number of vowels. So the even number of vowels could be 0, because even though it's non-empty, it could be some consonant that makes it non-empty. Or the even number of vowels could be 0 number of vowels. The odd number of vowels has to include at least one vowel. Well, that's pretty obvious, I think. We assume that Bob and Alice so what would happen if Bob always tried to take 0 vowels? I think that would probably mean that Alice likely wins. Let's look at some examples here. So Alice wins in this case. So there's 1, 2, 3, 4 vowels. So if Alice takes, she can take 3 vowels or 1 vowel. Say she takes 3 vowels. Say it's like this. And then Bob would have to take the single R. And then Alice would take the last E. And then Bob wouldn't be able to take anything. Or, okay, yeah, so it looks like if she just takes everything including the O, not including the D, and then Bob takes like the D or the R, and then Alice takes the final 2. If Alice takes the minimal substring, like E to O, it'd be LDER. At that point, Bob could take, I think Bob is screwed. Bob can't take everything. Pretty much you have to take everything remaining in order for the other person to not be able to take anything, and then they lose. Or somehow Bob gets Alice into a position where she doesn't have a vowel to take. Okay, well this one's this E to this E. Yeah, Bob is, if Alice has just taken a single E, could Bob win somehow? I don't see any way Bob wins. Alice does a valid move. Single E here, Bob would have to take, I don't know, a single D. No, then Alice just takes everything. Okay. This one, B, B, C, D. House fails the first one. Pretty damn long string, 10 to the 5th. Well, obviously this one, you just can't simulate all the ways, I don't think, to do the move, so this one boils down to, my guess is not possible to simulate every move, which actually makes this a less interesting problem, because there are problems where it's Alice and Bob playing and then you have to actually simulate all the possibility that Alice does, and then Bob does like some sort of possibility tree for, you have to like go into like some sort of depth analysis of the decision trees, like min-max on the decision each time. Anyways, so likely boils down to some calculation or simple computation based on the counts of consonants and vowels, and possibly their relative locations, like maybe how many long kind of the permutation of the sequencing of them. So is there an optimal way that, so question, is there an optimal way of deciding what to take as substring for any move by Alice or Bob? So if there is, then you just kind of do the greedy approach. Is do greedy analysis to determine movements. So you just like simulate each person doing their optimal move, and then you get to somewhere. What makes sense here? Would it ever make sense for a player to do like the longest substring that they can, or the shortest? So, for instance, is it optimal, or can it be, to always take the longest substring possible? Because in theory, taking the longest possible would, if you're one move away from winning, then taking the longest possible would basically remove everything and then you would win. So can I come up with a counter example where it is incorrect, or what's the term? Non-optimal to take the longest substring possible. So let's go ahead and consider that. So in the first example, I think the longest possible would be something like L to D, in which case Bob does R and Alice does E, so that's one thing. Take the longest possible. Theory, it could be slightly longer if this is E to E, and then there's a bunch of constants after that. Or it might be just equivalent. Could it be equivalent? Val. Should be able to come up with a very finite example of a counterexample. Example of a counterexample is the same thing as a counterexample. So if we're dealing with Alice, and let's say Alice should be taking something shorter than the longest possible in order for her to win. And Bob would win if Alice takes the longest possible, but lose if Alice takes something shorter than the longest possible. Yeah, I'm having a hard time thinking of that, so I'm going to go with that and see if there's any test cases that just need to be considered. But this is definitely not kind of the ideal way of solving this, like just seeing whether failed test cases. I guess maybe in the context of Leetcode, given what you're able to do within the interface, maybe it's something of a design assumption for the solutions, an assumption for the design of the solution. In any case, how to find the longest possible substring to take. How to find the longest substring to take. Even matter? Does it just boil down to the number of vowels? Like boil down to the number of vowels. If there's 4 vowels, then the first person takes 3, which is the most number of vowels. The next person takes 0, because there's no even number of vowels. And then the last person takes the remaining. So if it's an even number of vowels, then Alice should always win. I don't think there's any scenario where Bob can win the case. Yeah. So can Bob if there's an odd number of vowels, can Bob always win? If there's an odd number of vowels, then Alice should just take everything, no? Just take the whole string. Okay. If there's an even number that's 0 vowels, then obviously Alice loses. If there's an even number that is not 0, so like 2, I think Bob just loses. Bob straight up loses. Huh. And if there's... Okay. Well... For all lowercase, I think. A, E, I, O, U. For every letter in the string, if letter is in the vowel set, then the vowel count increments. If the vowel count equals 0, then return true if Alice wins, right? This returns false. Otherwise return true. Should win for the test cases, I'm sure. Let's see what test cases, or these two example cases. Let's see what test cases it fails in the broader subset. The broader set. Okay, I guess that was the quick logic. Interesting. Okay, that's interesting that this is so slow compared to things. Actually, so I think what this means is if I see a vowel, then I can immediately return true, because as long as there's 0 vowels. Okay, so if I see a vowel, then just return true. Otherwise, return false. I'm pretty sure that's what's the difference between the speeds here. Oh my god, what the fuck? 0 milliseconds? Alright, okay. No declaration of the vowel set. We'll just do a static vowel set here. Okay. No vowel count as well. Come on. Bullshit. Okay. Really? For every letter in the string, if the letter is in the set, how can you do faster than that? For the love of God. How can you do faster than that? What? Alright, I'm going to run it one more time to see if it's just random variation. It's somewhat random. I'm awfully tempted to see what this 0 millisecond runtime solutions are, because if you just give me this, like this code, and ask me, is there a faster way of doing whatever this is doing? Like, in your wildest dreams, you just come up with anything that Python can do syntactically that is functionally equivalent to this, that's faster. I would say you're joking. Every letter in the string. The letters in the set and an if statement. Well, is there contains in Python? Yes, I could just convert the string into a set. If A in S or E in S, I in S or O in S or U in S, maybe something like this. Just straight up return that statement. I might need to convert S into a set. Oh my. Okay, this is the this faster way of doing this. This is the slower but perhaps easier to understand. Okay. Alright. I guess that was the vowel game. In summary, this boils down to this is more of a logic problem, I think, rather than coding problem. It doesn't require very much complex coding. I mean, it doesn't require any complex coding. So logic for how to determine wins. Any odd vowel count string, Alice will win by using the whole string on her first turn. Any even vowel count, any non-zero even vowel count, Alice will win by taking n-1 vowels, leaving one vowel at least, or leaving exactly one vowel. Either anything that Bob does will not remove that vowel. He takes a zero vowel substring and Alice can follow up by removing the remaining string on her turn and win. Thus, the only time Alice loses is if the string has no vowels to start. This is example 2. Thus, code simply checks if val exists in string, and if not, else wins. If so, if no vowels, else loses. This returns false, and this thing is returned true. Anyway, time complexity, this is going to be O of I think this counts as O. I mean, if you check for existence of an element in a set, I want to say that should be O of n. Time complexity, check for existence of element in a set. I think that's O of n. It's O of 1, really. Okay, yeah, this is average case. Time complexity is constant. In the worst case, it's O of n. Of n. Worst case to check for existence. Yeah. No, generally checking for things in a set is O of 1. That's why we do it so often. I mean, to convert something to a set is O of n, no? Time complexity to convert array to set in Python. Yeah. Well then, to convert slash check, convert array to set or slash check existence of vowels set. Note that once converted, that it should be O of 1 to check if element is in set. Yeah. Space complexity, this should be O of n. O of 1 if array kept in array, and O of n if converted to set. And I think the fast way here, I actually don't know. It should be keeping in an array, and that should be O of n, I think. It went much faster. Maybe there's an implicit conversion into a set here. We'll double check and think S equals set of S. Maybe it's an implicit conversion. No, it's not. It's something faster than implicit conversion. I don't understand this. What is the speed of Python in operator for arrays? It's the prompt linear search. This should in theory be O of n, but it seems to be much faster than that. Yeah, I don't understand why this is so fast. If it's the same speed as iterating with the array, it should be, yeah. And even converting the string into an actual set, it goes slow.